Welcome to our first lesson in our new unit on plane geometry. In this lesson, our learning goals are to calculate unknown angles. We are going to do this using the properties of straight lines. There are three theorems we are going to look at: the supplementary angle theorem, the complementary angle theorem, and the opposite angle theorem. We are going to be calculating the angles using these theorems and not using a protractor. The first theorem I mentioned is the supplementary angle theorem, or SAT for short. This theorem says that all the angles on a straight line add to 180 degrees. So here we have a straight line, and then we have this other straight line that comes and cuts this straight line. We see that two angles are formed, A and B. Both of these angles, when added together, make 180 degrees, add to 180 degrees. We could also split up a straight line into three different angles. So here it would be angle A, angle B, and angle C. These three angles, A, B, and C, would add to 180 degrees. The second theorem is the complementary angle theorem, or CAT. This theorem says that angles that make up a right angle add up to 90 degrees. We know that the angle here between these two lines are 90 degrees because of this little square that indicates that there's a 90-degree angle, and it is cut, this 90-degree angle is cut by this other line. So it splits up the 90-degree angle. So we know angle A plus angle B is equal to 90 degrees. Our third property is the opposite angle theorem, or OAT. Here we have two straight lines that come and cut each other at an angle, and we can see four angles are formed. This theorem says that the two opposite angles are equal to each other. So here angle A is equal to angle B, and angle C is the same as angle D. Those are the three theorems that we will be focusing on in this lesson. On the next page, we are going to be practicing these theorems. We will now do 4 questions to practice the theorems that we just discussed. In question 1, it says the supplement of 72 degrees is blank. The supplement is the theorem that involved the straight line. The short form was SAT, supplementary angle theorem, and this said that all the angles on a straight line add to 180 degrees. So in this question, the acute angle is 72 degrees. So to find the other angle, we have to subtract 72 from 180. And this is 108 degrees. In question 2, it says the complement of 54 degrees is blank. Well, the complementary angle theorem, or CAT, states that angles in a 90-degree angle add to 90 degrees. So if one of the angles is 54, to find the other angle, we do 90 take away 54, which is 36 degrees. In question 3, it says, without measuring, calculate the indicated angles in each of the following. It says without measuring, meaning do not use a protractor, use the straight line theorems. So let's look at this first one, angle that we have to find. It says we want to find angle HGF. So that would be from H to G to F, so this unknown angle. We see that this angle and 122 degrees form this straight line. So to find this unknown angle, I'm going to take 180 minus 122, because angles on a straight line add to 180 degrees. This is equal to 58 degrees, and we should state our reason. We said we use the supplementary angle theorem to find this unknown angle. In the second problem, we want to find angle ABD. We say that we have a 90-degree angle here, and it is cut, where one of the angles formed is 65, and then to find the unknown angle, we have to take 65 away from 90 degrees, which is 25 degrees. And again, we have to state the property we used. We use the complementary angle theorem because that states that the angles in a 90-degree angle form 90 degrees. In question 4, we are asked to find, again, unknown angles, and it says state the reason that we used. So that would be SAT, CAT, or OAT. This first example, A, we see that we have two straight lines that cross each other, and we have A, which is opposite of 100. So we know A is equal to 100 degrees because of the opposite angle theorem. Those two angles are opposite each other. So I will write OAT. In B, we have a bunch of lines crossing each other. So we have to be very careful about what is opposite of which angle. So I will shade here. I see angle B. Angle B is trapped by this line in pink and this other line, which I'm shading in pink. So B is trapped by the two pink lines. 62 is also trapped by those two pink lines. So those two angles are opposite each other. So that means angle B has to be the same as the one opposite, which is 62 degrees. Again, because of opposite angle theorem. Now I'm going to try to find angle A. Angle A, I will shade now in blue. So I see here angle A is shaded by the two blue lines, but the angle across from that, or opposite of angle A, is not given. Therefore, I cannot use opposite angle theorem. So I'm going to get rid of these lines and try to find a different way to solve this problem. Opposite angle theorem did not give me the answer, so I'm going to try to use supplementary angle theorem. I don't have a 90-degree angle, so I'm not going to use complementary angle theorem. And if I look, my angle A lies on this line. So that means all the angles on that line have to add to 180 degrees. I know B is 62. This angle in here is 35. So to find angle A, I take 180 degrees and subtract the other angles along that line. And I get 83 degrees is angle A, and the reason is supplementary angle theorem. And finally, in 4C, I have three angles to find, X, Y, and Z. So I have one angle given, the 110. So I'm going to use that angle. I can see that lines are crossing, so I'll probably use OAT, opposite angle theorem, at some point. So the 110 degrees is trapped by these two pink lines, and on the opposite side, these two X values are trapped by these two pink lines. So the total value of these two X's is 110 degrees, but I only want one X, so I'm going to divide it by 2. So the value of one X is 55 degrees. And again, I used opposite angle theorem to find that. You could have also made an equation here. You could have said that the two X's